Welcome. Welcome to this afternoon session with Benjamin Shu. He will be sharing with us about extending your FHIR server with proxy services. Our recording has started and we will go ahead and begin the presentation.
Okay, I think we can get started. Thanks so much for attending my session, Extending Your FHIR Server with Proxy Services. A bit about myself. My name is Benjamin Shu. I'm a Senior Program Manager with the Healthcare team at Microsoft. In this session, I will talk about two proxy services that you can work with the FHIR Server. The first one is FHIR Proxy, which provides authorization compatibility to access FHIR data, either from within an EMR application or a standalone application. And the second one is an open source FHIR proxy, which enables you to extend FHIR server capabilities. For example, managing user roles and their data access. There are different FHIR server implementations available, but in the demos, I will use the Azure API for FHIR, which is a managed service available in Azure. However, the two proxy services can be used in open source FHIR servers as well. FHIR is not something new. I bet many of you are familiar with it. In fact, there are a couple of FHIR sessions at DevDays. I encourage you to attend them or watch the video to learn more. With the short amount of time we have here, I will focus on the FHIR proxy. The main reason why you may need such a proxy service is that FHIR servers, such as Azure API for FHIR, may handle authorization differently than the FHIR application. The proxy service ensures compatibility between them. In the demo, I will use the built-in proxy service available in Azure API for FHIR, which relies on Azure Active Directory for authentication and authorization, and a standalone JavaScript application. When the user request is submitted, the FHIR application server, the FHIR authorization server, in this case, Azure Active Directory, authenticates the user and redirects the request to the FHIR proxy along with the access token. The proxy service then retrieves the data from the FHIR server and returns it to the user. There are a number of steps to go through, which is well documented. You first create a FHIR server instance. You then enable FHIR for the server. You register a public client application, which is used to obtain the access token. You set up the reply URL, which is a combination of the FHIR server URL plus AAD smart on FHIR proxy /callback, plus the URL for the JavaScript application. As you see, the portion for the JavaScript application URL is base 64 encoded. For the demo, I'm running the application locally, but you can certainly deploy the application and run it in the cloud. The source code for the demo app is available from the open source FHIR Server GitHub repo. Here we updated the FHIR Server URL and specify the public client application ID in the HTML file on the left side, On the right side, you have the HTML file to display the data. If you configure everything properly, you should see the patient data. As you can see, it is fairly easy to use the built-in smart FHIR proxy service. The proxy service provides basic functionality and will continue to improve it. If your FHIR server needs to address the authorization compatibility issue, you or your development team can take a look at how the smart FHIR proxy service is implemented in the GitHub repo. Now let's shift the gear to look at another FHIR proxy service. The FHIR server is implemented based on HL7 FHIR spec, but there may be some technical capabilities that aren't natively available in the FHIR server, but you must support them in your application. This is where the FHIR proxy comes into play. There are many reasons why you may need such a proxy service. I list a few here. How do I manage users and their data access? Can I do some validation before posting data to the FHIR server? Can I format the data differently? And the list goes on. The requirements typically fall into two categories. You will need to do something before the request is processed, or after the request has been processed, but before the data is returned. The FHIR proxy project does exactly that. It was created by the healthcare architecture team at Microsoft. As you can see, it comes with a few supported scenarios. For example, publish a FHIR post event process. This processing module will publish FHIR create, update, and delete events for resources to a configured destination, such as Azure Event Hub. These events can be subscribed to by any number of consumers in order to facilitate any number of orchestrated workflows. You can certainly take the same concept and create something for your own FHIR server. In the demo, I will show you how to extend a post-process module called DevDays process. I try to keep the scenario simple so that it is easier to see how you can extend the proxy with your own business logic. Here is the FHIR proxy module in C# code. At top, I implemented the iProxy post-process interface. Then I handled the GET request only. And then I manipulate all resource data from the GET request, for example, patient data, and replace the data with an array of the resource type and the resource ID only. As you can see in the red rectangular box. The FHIR proxy is deployed as an Azure function. We specify the confidential client application ID, the secret, the tenant ID, and the FHIR server URL. Also, we specify the post-process type as DevDays post-process. Here is a view of the returned data from the Azure function. As you can see, the FHIR proxy is very extensible in terms of what business logic you can implement. So in this short talk, we've briefly discussed the two proxy services, the built-in smart FHIR proxy service and the open source FHIR Proxy, and how they are used to extend the capabilities of the FHIR Server. Here are some resources we referenced in the discussion. My contact information here, email benjamin.shu@microsoft.com. That concludes my session. Thank you very much.
Okay, Benjamin, thank you so much for that presentation. And I wanted to just invite questions if participants want to post questions in Whova. Benjamin and I are monitoring Whova for any questions, or if you would like to be unmuted, I think we could possibly do that and Benjamin can entertain some questions. You also could message him as he provided his information, or contact him via Whova as well. So we'll wait just a short time here for any questions. And then maybe Benjamin, if there are any closing comments you want to make.
Sure, we'll see if there are any questions. But again, thanks so much for your time here. Those are just two examples that you can always extend your FHIR server, particularly if you're using some open source server where you have more control in terms of what capabilities you can add on top of that. The good news is that both actual proxy service are, the source code is available from the GitHub repo, which I have the links. One thing I do want to mention is that the link to the FHIR server, we just moved from one place to another place. I think in my updated slides that should have that. It's the github.com/Microsoft FHIR proxy. So if you can, if you're interested in the FHIR proxy open source, you should be able to find it. Again, if you have any trouble to find the URL, my apology for during the talk, the recording, I think we updated that repo just to make it broadly available to the developed community. So you can always find me from the speaker gallery or you can email me directly.
Mm-hmm. Okay, good. And I have not had, oh, I think we may have one question here. And you may just, it says, could you paste the current links to the GitHub repos or a link to the slides? Well, definitely the slides will be made available, but Benjamin, yeah, go ahead.
Let me actually share my screen so that you'll be able to see that.
Okay.
My browser. I think it's github.com/ I think it's yeah. So is that IAM window? I can, if not, I think this is the URL. Actually, I'm not able to find an IAM, so I've tried the low-tech option, so you can see that. Such a pretty clever implementation. We've got customers who want to do things that using different sort of identity platform, and yet they want to use either the Microsoft FHIR open source server or the managed service. So this is the one solution, one option. You can look at the open source and then implement your logic from there.
Excellent.
Yeah. In my demo code, again, I'll be happy to share the demo code. As I said, I'll try to keep it simple so that you can see it naturally. This is just a few simple processing. Make sure that you only handle the GET request in my particular case, and then I'll basically enumerate all the resources depending on the situation. Right. In my case, I just get all the patients. I only kept the 10. So I basically say, okay, enumerate all the patient resources where I just basically do whatever I need to do here. This is kind of the logic. And then I just replace the response with my data. You can embed, for example, the smart on FHIR scope, which I think had a plan to support it in the future. So if it's something you want to do that in your FHIR server, you can actually use the FHIR Proxy, and then you can define the user roles, provide the scope for each user, whether they are just end users versus clinicians, administrators, so you can manage the application from there. So it's actually pretty flexible, extensible.
Mhm. Okay. All right. We don't have any additional questions that have been posted. So I think at this point, unless Benjamin, is there anything else that you would like to share as a closing remark? Or if not, we're about ready to wrap up.
Yeah, I think we can wrap up. Thank you so much, Patricia, for both of you for your support. Again, I'll be available at the Speaks Gallery, and also you can ping me if there's any follow-up questions. Thank you again for all of you for attending the session.